Hello, and in today's video we are going to be looking at the effective annual rate, or EAR, and how to use that for some time value of money problems for your CFA Level 1 curriculum. This effective annual rate material can be found in Reading 6 and its learning outcome C as part of Reading 6. So let's get straight into it. So interest rates can be presented in a couple of different ways. The first is the periodic interest rate, whereby we're given the interest rate earned over a single compounding period. So for example, if we are compounding quarterly, we might get the interest rate presented as 3% interest per quarter, and that's compounded quarterly. And so we're getting 3% 4 times a year, essentially. Now, if we wanted to convert that into some sort of an annual rate, how much interest are we earning per year? There's a couple of ways we can do this. One way is by using the stated annual interest rate, or the quoted interest rate. And this is sort of a bit of a convention in the finance industry. The problem with the stated annual interest rate is that it does not account for compounding within the year. So if we use our example from before, where we had our rate of 3% per quarter, if we multiplied that by 4, that would give us a quoted rate of 12% per year. So all we've done is taken our quarterly rate of 3% and multiplied it by the 4 quarters over the course of a year. So this gives us our quoted interest rate, but it doesn't take into account our compounding over the quarters. We've just taken that raw rate and multiplied it by our periods. So an alternative measure and more effective measure that we can use to measure our annual rate is the effective annual rate, or EAR, which is the whole purpose of today's video. So this does take into effect the compounding, and so as a result, when we calculate our EAR using our above example, we're actually going to get a number that's greater than 12. So our EAR is going to be greater than 12 because compounding will be taken into effect as part of our EAR calculation. So to calculate the EAR, we're given a formula here which might look a little bit intimidating, but it's really pretty straightforward. So we've got our EAR equals 1 plus this is our quoted annual rate divided by our n number of periods. So in this example above here, our R divided by n is going to be our 12% divided by the 4 quarters in the year. So R over n would just equal 3%. We add that to 1. And then we raise that to the nth power. So in this case we have 4 periods because it's quarterly. So that will be raised to the power of 4. And then we subtract 1. And that's going to give us some number that's greater than 12, which will be our effective annual rate, and that's taking into account the compounding over the course of the year. So it's just 1 plus our rate per period to the power of the number of periods, and then subtracting 1 to get our percentage rate. So the easiest way to look at this is probably through some questions. So I've got a couple of different CFA style problems that might help you understand EAR a little bit better. So question 1, if an investment provides a 2% return semi-annually, its effective annual rate is going to be what? So using our effective annual rate formula, that's going to equal 1 plus our 2% return. It's semi-annually, so n is equal to 2. So we have 2 periods and subtracting 1. So that's going to give us a effective annual rate of 1.02 squared minus 1. Which is going to give us a rate of 4.04%. So our answer would be B. Question 2. An investment provides a 3.1% return quarterly. What is the effective annual rate? So our EAR is going to just simply equal the 1 plus our rate per period. We're dealing with a quarterly time horizon here, so it's going to be raised to the power of 4, and then we're going to subtract 1. So we're going to be left with 1.03 to the 4, and take 1 off. So that's going to give us 12.531 to the 4, sorry. 12.99%. And so our answer is going to be B. Question 3. A bond with a par value of $1,000 and 20 years to maturity has a current price of $850. So we've got some bond that's priced at $850. The yield to maturity is 12%. The coupon payments are 10%, and they're paid annually to start off with. So a bond is basically just an instrument whereby an entity can borrow money from another entity and then they pay it back with interest over a period of time. So if interest on the bond were paid semi-annually instead of annually, and the bond continued to be priced at $850, the resulting effective annual yield to maturity would be what? More than 12%, less than 12%, or 12%. So we don't even really have to calculate anything here. But what do we know about effective annual rate? Well, it takes compounding into effect. So our effective annual rate is going to be higher than just a quoted rate. And we know that the more periods, the greater the effect of compounding. So the more periods, the greater the effect. So if our bond is still priced at $850, but our interest payments now are compounded semi-annually, we're actually going to get a effective annual rate that's greater than 12% because we're compounding more frequently than we were before. So we're going to get a higher effective annual rate on our bond. So that means the answer is going to be more than 12% because our new rate is going to be compounded more frequently, and so our AAR has to be greater than 12 since that's what we started with. So A would be the correct answer there. Now finally, we've got our last question, and this is basically a bank that's offering a deposit product, a savings product, with an effective annual rate of 6.95%. So in this question, we know the effective annual rate. That's a given. It's 6.95%. It's continuously compounded though. So the advertised quoted rate is what we're trying to find. When we deal with continuous compounding, our EAR is actually equal to E, as in the constant E, raised to the power of R minus 1. So we're given our EAR here of 6.95%, and we actually need to try and find what R is equal to. So to get rid of the 1, we bring that across. So we get 1 plus the 6.95%. And then to get rid of that E, to find our R, we actually do the reverse operation of raising something to the power of E, is taking the natural logarithm of it. So on your calculator there'll be the ln button, so it's taking the natural log, and then inside that function we're just going to put 1 plus 0.0695, and that should get us our R. Which is going to be 6.72%. So our answer is going to be A. So I hope you have a bit of a better understanding of effective annual rates, and also understand the types of questions that you might come across involving effective annual rate calculations. If you have any questions, just leave a comment below, and thanks for watching.